Have you ever looked up at a giant airplane and wondered, how does that thing stay up there? It's a question that puzzled humans for centuries. After all, airplanes are made of metal, plastic and fuel, all things that are heavier than air. Yet, these incredible machines soar through the sky, connecting us across continents and defying gravity's pull. The answer, my friends, lies in the fascinating world of physics. It's a story of forces, pressure and clever engineering. From the pioneering experiments of the Wright brothers to the supersonic jets of today, our understanding of these principles has allowed us to conquer the skies. So, buckle up as we embark on a journey to uncover the secrets of flight. We'll explore the fundamental laws of physics that make it all possible. Get ready for a thrilling ride through the air, where we'll unravel the mysteries of how airplanes stay aloft. Prepare to be amazed by the invisible forces that keep us soaring high above the ground. To understand flight, we need to start with the basics, Sir Isaac Newton's 3 laws of motion. These laws, established way back in 1687, are fundamental to understanding how objects move, both on the ground and in the air. The first law tells us that an object at rest stays at rest and an object in motion stays in motion at the same speed and in the same direction, unless acted upon by an unbalanced force. Think about a ball rolling on the ground. It will keep rolling at the same speed and in the same direction until something stops it, like friction or a wall. The second law explains how force, mass, and acceleration are related. It states that the force acting on an object is equal to its mass times its acceleration, F equals sine ma. Basically, the heavier something is, the more force you need to make it accelerate. Imagine pushing a shopping cart versus pushing a car. The car needs a much bigger push, force, to get moving. Finally, the third law states that for every action, there is an equal and opposite reaction. This is the law that really comes into play with flight. When the wings of an airplane push down on air, the air pushes back up on the wings with an equal force, creating lift. We'll delve deeper into this later. So, while Newton himself never flew in an airplane, they weren't invented yet, his laws laid the groundwork for understanding the forces that make flight possible. Now let's talk about air. It's all around us, yet we rarely think about it. But air is much more than empty space. It's a fluid, just like water, and it exerts pressure on everything it touches. This pressure is called air pressure. Air pressure is the force exerted by the weight of the atmosphere pressing down on the Earth's surface. At sea level, this pressure is about 14.7 pounds per square inch. That's like having an elephant standing on every square inch of your body. Don't worry though, we don't feel crushed because our bodies are also filled with air, which pushes back with equal pressure. But here's where things get interesting for airplanes. Air pressure decreases as altitude increases. This is because there is less air above you pushing down. Think about a stack of pillows. The pillow at the bottom feels the weight of all the pillows above it, while the pillow at the top feels almost no pressure. This difference in air pressure is crucial for flight, and it's where Bernoulli's principle comes into play. Before we dive into Bernoulli's principle and how it relates to lift, let's take a quick trip back in time to December 17, 1903. On a blustery day at Kitty Hawk, North Carolina, 2 brothers from Ohio, Wilbur and Orville Wright, were about to make history. These bicycle mechanics turned aviation pioneers had spent years studying bird flight, experimenting with gliders, and building their own lightweight engine. Now they were ready to test their creation, a flimsy biplane called the Flyer. With Orville at the controls, the Flyer lifted off the ground for a grand total of 12 seconds, covering a distance of 120 feet. It was a short flight, but it marked a pivotal moment in human history. The first successful controlled, powered, and sustained, heavier-than-air human flight. The Wright brothers didn't have access to supercomputers or wind tunnels. They relied on their ingenuity, determination, and a deep understanding of the fundamental principles of physics. Principles we're still exploring today.